Hello and welcome to Educational Psychology. Today we'll be focusing on our first competency, 1 out of 13, that you will learn to prepare yourself for the Pedagogy and Professional Responsibilities exam, or PPR test, which you will be required to pass to be a public school teacher in Texas. For our first competency, since it's a pretty large competency, we're actually going to break it down into different parts. And so for this topic, today will be students' cognitive development. And in particular, we're going to be focusing on one theorist, John Piaget. Let's begin by discussing the competency itself. So the competency says that the teacher, or you, will understand human developmental processes and apply this knowledge to plan instruction and ongoing assessment that motivate students and are responsive to their developmental characteristics and needs. Today, actually, we're going to kind of break it down, like I said earlier, and we're going to focus primarily on human developmental processes and applying that knowledge. Without further ado, let's begin with our topic, students' cognitive development. And so just to remind everyone, cognitive means like brain or intellectual development. So how people grow as learners. Let's begin with one of the principal theorists in educational psychology, Jean Piaget. Jean Piaget was a constructivist theorist, and we'll explain more about constructivist theory in a little bit, who conducted most of his psychological research in the first half of the 20th century. Although I put that on the slide, it's actually true that he even continued with his research up into the 60s and 70s, so it was pretty amazing. He had a very impressive and long academic career. His focus was on how children develop cognitively, and also how children's thinking is different than that of adults. And the way he formulated his hypotheses is that he studied children's learning development from birth until adulthood. And in fact, it's kind of interesting. Some of the people or his test subjects that he observed in significant detail and then later used to formulate his theories were his own children. As I mentioned earlier, Jean Piaget was a constructivist theorist. He believed that students do not passively receive information. They don't just, if you say it out to them, they don't automatically just memorize it and retain it. Instead, children learn best, and they primarily learn through creating their own knowledge and understanding. And the way they do that, the way they construct their own knowledge and understanding, is through exploring their environment and interacting with living things. And so, even as adults, we can also, the more you interact with different types of people, or people from different areas, or also different types of animals or different types of plant life, that helps you to construct new knowledge that you add on to your pre-existing knowledge. Constructivist theorists also argue that intelligence is not something that's just simply innate, that you're born with, but rather a lot of it has to do with how you organize information and how you adapt to your environment. One of the principal foundations of Piaget's theory on how children learn and develop intellectually, or their cognitive development, is the concept of schema. So schema is how information is stored or retained, and how it also is organized in a person's mind. Another way to think of it could be basically someone's pre-existing or prior knowledge. And so Piaget argued that children learn new information through two different interactions with their prior knowledge, their schema. So the first interaction is called assimilation. And so this concept says that basically students add on or expand on their pre-existing knowledge, their schema, and they connect what they have just learned, new concepts, to their prior understanding, their prior schema. So an example I put here is that if students in second grade in Texas, for example, learn how to add two-digit numbers, and they even learn how to add two-digit numbers with regrouping. So if you were teaching adding three-digit numbers in third grade, then your students are building upon their prior knowledge because they can transfer or bring in a lot of information that they learned from adding two-digit numbers to adding three-digit numbers. And so they're expanding or assimilating and building upon their pre-existing schema of two-digit number addition. On the other hand, students also accommodate information. So accommodation is actually when students correct previous misunderstandings or incorrect schema with new information that is correct. And so an example I gave is that probably as a child, many children see anything that's swimming in the water that has fins and that lives in the water full time as a fish. And so they're later taught that fish lay eggs. However, later, students have to accommodate new information. They have to correct the misconception that all things that swim in the water and have fins lay eggs, because in fact, whales and dolphins are mammals. They are not technically fish, and they give live birth. They even nurse their young with milk. And so a child might not necessarily know that, but eventually, through schooling and through learning, they accommodate and correct that misconception that everything that's in the water that swims and has fins has to lay eggs. Piaget further detailed that through repeated practice and through specifically repeated practice of new assimilation, where you're expanding on your prior schema, your prior knowledge, eventually that knowledge becomes a reflex. It becomes automatic. And so an example I would give is many of you probably played softball or baseball as children, and maybe even today. In the beginning, you don't really know how to swing a bat, but your coach or your parents teach you how to swing a bat, and eventually it doesn't become an awkward sensation where you're moving your hands, but rather it becomes something automatic, something that you do instinctively, and you end up having the correct form through repeated practice. So it becomes a reflex. And the reason why it becomes a reflex is also because it's been encouraged. Each time you gradually improve your swing, your coach or your parents or your friends said good job. Also, you were more likely to successfully hit the ball. And so in your mind, you also internalized that, hey, this is a good action, the good strategy to swing a bat. And so since that reflex was encouraged, it became automatic. And so eventually you didn't have to actively think in your mind, I have to use my prior knowledge of holding on to a stick and moving my arms to make a swing. Instead, it just became automatic. This is a bat and I already know how to swing. However, on the other hand, reflexes can often be discouraged or stopped. And many times, reflexes will be discouraged or stopped in the hopes that it will disappear. And so in this case, the student or the child is not assimilating and building onto their pre-existing schema or prior knowledge. Instead, the student is accommodating and correcting previous incorrect understandings or inappropriate behavior. So they use accommodation to change their behavior and to rewrite their schema. So an example might be, as a child, as a baby, you'll often begin life eating with your hands. You'll probably make your face and maybe your arms dirty, and then hopefully your parents help you to clean yourself. However, later when children start getting older, parents start to encourage children to use utensils like silverware, and they start to also encourage children to clean up after themselves and to wash their hands before they start eating and to wash their hands after eating. And so that ends up becoming an accommodation. So it takes away the pre-existing schema that the child had of, hey, I see food, let's grab it with my hands and just eat it as fast as possible, and who cares if I get dirty? Instead, it eliminated that reflex of, I'm hungry, let's eat as fast as possible, and replace it with, I'm hungry, however, there are social norms and it's important to have good hygiene. So I'm going to replace my instinct of grabbing the food as fast as possible, because that has been discouraged by my parents and my peers, and instead I'll be using a sophisticated or polite way of eating, which then my parents, my brothers and sisters, my friends all applaud and say, "Great! Oh, how great he's eating!" or they look happy. So that's how the child naturally accommodates and ends up eliminating the reflex to grab food. However, it is really important to note that in order for intellectual development to occur, children need to practice both assimilation and accommodation. So when they have correct prior knowledge or correct schema, they want to build upon that. However, when they have incorrect schema or incorrect behavior, they hope to replace that incorrect behavior and accommodate that with new information that is correct. Eventually, if they keep on focusing on that correct new information, that becomes their new schema. So another way to think of it is that students need to assimilate or deepen their understanding to fully grow intellectually. So maybe they might understand that fire is hot, but eventually they might expand that to realize that anything bright that has energy is very hot, like a light, or like maybe an iron. At the same token, as we mentioned earlier, if a student has a misunderstanding, let's say they assume that maybe adding two-digit numbers without regrouping is the same as adding two-digit numbers with regrouping, and they correct that and realize, if I have to regroup, it's a different process, then they correct that misunderstanding, they accommodate it, and eventually that becomes their new schema. It becomes automatic eventually as a reflex. So right now, you already know how to regroup by adding two-digit and three-digit numbers, maybe, of course, larger numbers. So you're not actively thinking if I gave you a problem, maybe let's say 85 plus 79. I should correct, you are actively thinking, like you are thinking, but it's not something that's so noticeable in your mind. You're not metacognitively tracking yourself and wondering how to do it. You are most likely doing it out of reflex. It's automatic. So yes, you're thinking, but it's become so ingrained in your schema that it's a reflex and it's just instant. Another thing to note, very importantly, is that Piaget argued that when students feel comfortable and knowledgeable about a topic and they feel confident, they feel a state of equilibrium. So equilibrium means basically they feel that everything is fine, everything is balanced. However, when new information is introduced, or an unexpected situation, or someone contradicts what they've been taught, students start to feel a sense of disequilibrium. They feel like things are out of balance. Wait, do I not understand the world? Is there something I'm missing? Am I incorrect? And so Piaget argues that because people have a desire to return to equilibrium, to return to balance, and to feel confidence in your knowledge, that drives students' interest in learning. So they're willing to both assimilate or expand on their prior knowledge, or accommodate or correct their incorrect misconceptions, because they want to return back to an equilibrium where they feel confident that they are knowledgeable and that they know all that they can about that subject that they need to know to be successful in their environment. Going back to the concept of equilibrium and disequilibrium, I wanted to give an example. So, for example, if a child thinks that they understand nature, like they understand that, let's say, all birds, in the beginning they see that all birds have wings, and all the birds they see in North America fly. And so in the beginning they think birds naturally fly. But then later they see a movie of penguins, and they learn in the movie that penguins can't fly. In fact, they never see a penguin fly or leave the ground. And then they learn about ostriches that also don't fly. Maybe they even see an ostrich in their community. When they see that the first time, they start feeling a sense of disequilibrium. Like, what's going on? Everything I thought before was wrong. Birds can fly, and some birds can't fly. And so it gets confusing for them. But then they also have a thirst or an interest in going back to that equilibrium state. So then they're going to want to learn more about penguins and learn more about ostriches and other birds that don't fly. That way they can formulate a rule in their mind. Most birds fly. However, penguins, ostriches, and some other birds that they learned do not fly. So especially large birds that are not proportional, they have, like, let's say, very large bottom parts of their body, will most likely not fly. Going back to the concept of reflex, another term that Piaget used to kind of discuss automatic or memorized routine or understanding was a script. And so he also argued that a reflex could be more for like an action that automatically happens, but a script would be more of like your memorized routine or memorized process that you use academically. And so his argument was that, once again, people will connect their new knowledge based on, or a new situation based on their prior scripts that they kind of memorized or ingrained in their brain. So another example of this would be, let's say in kindergarten, students learn that a sentence begins with a capital letter and ends with a period. Later, that becomes automatic when they're writing. And so when they get to first grade, they're not always thinking in their mind, I'm going to put a capital letter and a period. Many of them already know it's automatic. Later, in first grade, they add on to that, or they assimilate onto that concept by realizing, a sentence is a complete thought, and it has a period. It has a complete thought, it has a capital letter, and it has a period. So it has to make sense to the other person. It can't just be a phrase that's said quickly that the other person would not understand. It needs to be a complete thought. And then later in third grade, they assimilate further knowledge. And so the capital letter, the period at the end, and also the idea that it needs to be a complete thought is now a script in their mind. So they automatically are doing that. But then they add to that knowledge by realizing, a sentence also has a subject and a verb. So it has a subject, an object that does something, and it has a verb, the action. Finally, in fourth grade, students assimilate even further. It's so automatic that they don't think about putting the capital letter, they just do it. They automatically put a period at the end of each sentence. They automatically are using complete sentences. And They automatically know they must have a subject and a verb because they've practiced so many times. But then they expand on that knowledge and assimilate new information by determining other parts of speech. So they're adding objects in their sentence, they're adding adjectives to describe the object, they're adding adverbs to describe the verb. And so, as you can see, eventually through repeated practice, academically it becomes a script. So for this slide, I want you to take this time to reflect. So I gave a couple examples of assimilation and accommodation. So now I want you to think about your own examples. So when do you think students assimilate or expand on their prior knowledge or schema? And when do you think students accommodate or correct misunderstandings, which becomes their new correct schema? If you have someone next to you that's been watching this information or is familiar with it, take this opportunity to turn and talk to them and discuss it. Piaget argued that children across the world undergo 4 similar stages of cognitive development, but that development could be affected also by their experiences, their social conditions, and their level of maturation, or how fast their body matures. And so, although most people would go through these 4 stages, they might go through them at different times. So the ages listed in the next slides are not absolute, but rather they vary based on an individual's physical and cognitive development. The first stage of Piaget's stages of cognitive development is the sensorimotor stage. The sensorimotor stage occurs from birth to age 2. During this stage, babies learn through using their senses, and through also trial and error, through exploration. They also start to begin to move intentionally for purpose. So they might, after about 4 months, start to enjoy a specific toy, and they'll move for that purpose to play with that toy. Babies also begin to be able to combine several movements together for one purpose. So, for example, they'll be able to combine the movement of grasping for food with hands, moving their arm, and to move the food up to their mouth, then opening their mouth, and then moving their mouth and their jaw muscles to chew on the food. All of this is a complicated process that involves a sequence of movements. Another thing to remember as well is that students develop their language skills initially by listening. And also, after they've been listening, after about 4 to 6 months, they start to babble or kind of talk in nonsensical words. And eventually, by about 1 year, they start to speak. But primarily in the initial parts of childhood, they're learning through listening to adults model appropriate communication. In the beginning of the sensorimotor stage, from birth to about 1.5 years old, babies have to learn new information by immediately imitating or copying the desired action. If they do not immediately imitate or copy it, they will not remember it. However, later in the stage, by about 18 to 20 months, babies can start to have deferred imitation. That's just a fancy way of saying that they can see something and still remember it a few hours later, even a day later, without immediate practice. So, for example, a young toddler, maybe let's say a year and 7 months old, if they see that where the mom hides the cookies in the household, they might later remember that information and come back and take some of those cookies when a couple hours later when their mom is taking a nap. But a baby at maybe, let's say, 8 months, even if they could move around and walk, would not realize and remember that information without practicing it. Another important thing to note is that at the beginning of the stage, babies have to physically see something to know that it exists. So if they don't see it, or they see something and then it goes away, they think it's gone forever. However, later, as babies get older, by about 8 to 12 months, they start to develop this concept of object permanence. That means they realize that something exists even though they might not be able to see it currently. So an example I would give would be, let's say a baby is really attached to a family dog. If the family dog goes outside to use the restroom or to play, a baby after 8 to 12 months will not get stressed or get upset because they know the dog still exists and that the dog is still there, it's just not in visible sight. I want you to now think about our first case study question. And then later you're going to work with someone to share your answers. And then later you're going to share, hopefully, to a group so you can collaborate and determine what's the correct answer. And maybe, hopefully, have a discussion. So the first part of the case study question is, I want you to think of a developmentally appropriate learning activity for a student who was in the sensorimotor stage. So let's say you end up getting a job at a Head Start program. That's a government-sponsored preschool program. And you're working with year and 8-month-year-olds. What would be a good activity for them? You might even also think of it as like a future parent. What would you do for your babies, your hypothetical babies, or even your current babies, if they were 7 months old versus, let's say, almost 2 years old? Then I would want you to explain why this learning activity, what this learning activity would detail, and how you would determine if students successfully learned the concept. Finally, I want you to explain why the activity would be developmentally appropriate. And I want you to specifically reference some of the content that we just discussed in the previous slides to explain why this activity would be developmentally appropriate for someone in the sensorimotor stage. The next stage is the preoperational stage from ages 2 through 7. During this stage, children begin to talk much more fluently and much more fluidly, a lot more consistently and without pauses, and they begin to be able to communicate orally through symbols. So that could be they could communicate by using hand gestures, they could communicate by using sign language, or they could hopefully communicate by writing letters and reading. Still, students' understanding is intuitive. So they learn solely through personal experience. They can't make logical conclusions based on reasoning or based on something they have not actually personally experienced. They also can only understand things in one direction. So they can't think backwards or reverse an action. So if you taught students how to add, let's say kindergarten students at age 5, you taught them to add 5 plus 3, they can probably do that on one direction if they practiced addition and used manipulatives to help them see 5 apples plus 3 apples is 8 apples. However, if you ask them to immediately think backwards, what is 8 minus 5? They can't think like an adult or think like an older child and then automatically know that to reverse that action to get 3. During the preoperational stage, when students are ages 2 through 7, they are especially imaginative. They enjoy symbolic play. So, for example, they might try to use their spoon as a symbol for an airplane and pretend like the spoon is an airplane. Or that underneath the table is a castle. Also, during this time, you probably have seen this yourself with either your brothers or sisters or your own children or your nieces and nephews or your cousins. They doodle a lot and they like to draw. However, when you look at their picture, it's very unclear to the outside observer what they're doing. Yet to the student, they know exactly what they're drawing. Students also practice new information and assimilate new knowledge and learn social skills by role playing. So a lot of times they'll pretend to be parents or people in the community, like maybe a firefighter or a chef, and they'll even pretend to be animals. And if students learn from each other, from watching their other colleagues or their other classmates imitate things, maybe even new things they haven't seen before, they learn new concepts that way. So role play is very important. Hands-on kinesthetic learning is especially important for these children in this age. In the first part of the preoperational stage, children are egocentric. So their only viewpoint is that they can understand is their own. They cannot conceptualize that another person has a different viewpoint, a different experience, or that they also cannot realize when other people start to misunderstand or get confused in what the child is saying. Also, children are primarily talking to themselves. So they'll pose questions to them, they'll ask questions or they'll talk out loud, and it will appear that these 2-year-olds are, let's say, talking to each other, but actually they're talking to themselves. They're answering their own questions. They also are not that preoccupied on whether or not they are being listened to or understood by others. They're focused primarily on themselves. They're egocentric. However, after approximately the age of 4, children start to develop socialized speech. They start to communicate with others for a particular purpose, and they want to be heard. They insist to be heard. They complain if they're not heard or they're not being listened to. In the early stages of the preoperational stage, ages 2 through 4, children have animistic thinking. By that, they believe that objects that are inanimate, objects that are not alive, are actually alive and real. They have lifelike qualities. So an example might be a 3-year-old child might be very worried about a toy doll because let's say the child goes to preschool and the toy doll is left outside and they don't have a blanket in the winter. So the child thinks the toy doll is alive and real and will be really concerned that that toy doll does not have protection from the cold. Another thing to note is that children cannot provide multiple classifications of something. So let's say a teacher shows students a picture of 10 birds. 3 of those are cardinals and 7 of them are eagles. And then the teacher asks the students, are there more birds or are there more eagles? Well, the child is going to answer there's more eagles. They're not going to be able to realize, actually this is somewhat of a trick question. They're actually both types of birds. So they won't be able to distinguish that there's 2 different classifications. So they'll only be able to distinguish those things from name only. They won't be able to realize that, hey, a bird and an eagle have several. An eagle is a bird because it has several different qualities. It can fly. It has feathers. It lays eggs. In the preoperational stage, children also do not understand conservation. So they don't understand that an object can still be the same even if its appearance has been changed. So the example that Piaget used was an example of water glasses. So he noticed that when he had 2 different glasses of water, one tall and thin, the other one short and wide, and he poured water, the same amount of water from the tall and thin glass to the short and wide glass, students did not realize that actually the amount of water was the same. Rather, they thought that the tall and thin glass had more water just because it was higher in height. They didn't realize that actually the same amount of water was being poured from the first glass to the second glass, and no water had spilled, so really both glasses had the same amount of water. Just their appearance changed. Now we're going to do the same thing for our second case study question. So I want you to think, what would be a developmentally appropriate lesson activity for a student in the pre-operational stage? So let's say a student who's 5 in kindergarten. Or you could choose earlier if you want to do pre-K, or even at the later stages, let's say 7, which is about first grade. I want you to think and describe what would exactly happen during this learning activity and how you would assess or determine if students were successful in learning it. Then, I want you to connect it back to how this relates to the Piaget's theories. How do you know for sure this is a developmentally appropriate activity and that the learner will be successful while they're seeing this information while they're in the pre-operational stage of their cognitive development? The third stage of Piaget's cognitive development theory involves the concrete operational stage. This is when students are from ages 7 through 11. During this stage, students need hands-on activities to be successful in thinking in 2 directions. So let's say you have an 8-year-old in 2nd grade. They can now understand the connection between addition and subtraction, but they need manipulatives. They need counters, or they need objects to help them demonstrate visually and through personal experience how addition is the inverse of subtraction and vice versa. They also form, as we kind of mentioned earlier, new understandings primarily through using concrete objects and through direct personal experience. And they form that new knowledge based on connecting it to their previous knowledge, their previous schema. However, even though students are able to think in 2 ways, they're able to think forwards and backwards, so they can do an action and then reverse the action or undo the action, they still have trouble thinking abstractly. They have to have directly experienced or observed the object to truly understand it. Another way to think of it is they have to physically do the action or practice repeatedly before they have mastered it, or it's become part of their schema or become part of a script in their mind that's just automatic. So you can't just, as a teacher, let's say you're a 5th grade, well, maybe that's a little higher, let's say 4th grade teacher, that you have 10, 11-year-olds. You can't just tell them one time how to do 3-digit multiplication by 3-digit multiplication. Instead, you have to physically show them, and you have to have them repeat the process over and over. You have to have extensive modeling where they do it themselves. They won't be able to understand something that they haven't physically seen. Or if you tell them that, let's say, the sun is the largest stellar body in our solar system, they might not fully understand that unless you show them a model, and they create their own model in which the sun is the largest. Or if you show them a picture in which the sun is the largest object, the sun is much more larger than the earth, for example. Otherwise, they'll probably continue to have the conception that the earth is larger than the sun because the sun looks so small as it's far away. The good news is that at ages 7 through 11, or during the concrete operation stage, children can use logic to understand conservation. They can understand that objects are the same, even though they might appear different. And they do this by understanding the following. So the first is identity. They can understand that if you do not add something that's permanent, or if you do not remove something that's permanent, or something that's not been permanently changed, then it means it's going to be staying the same. So if the teacher one day comes to class with a funny hat and a large coat, the students will still know that is our teacher. They haven't changed personally, or their character hasn't changed, or their intellect hasn't changed. Rather, they've just done a superficial change in their appearance. So they still retain the same identity. So in that glass experience, that water glass experiment, the students would understand, hey, we didn't add water and we didn't take away water. We just poured it from one glass to the other. So actually, the amount of water is the same. Whereas a younger student, let's say a 5-year-old, would still think that the tall glass is larger, even if they saw it and they did it themselves and they poured each glass to the other glass and didn't add anything. Furthermore, they're able to understand reversibility. So they realize that they can undo an action by working backwards. And so an example of this would be, let's say they follow the steps to make a toy car and to connect the battery and to screw in the battery and then close the battery case. And they do all these steps. And then they also realize that, hey, I can undo the steps and break the toy car into parts and disconnect the toy car by removing the battery and step by step going backwards until I get to the initial parts that I began with. Another way they can understand conservation, or that objects are the same even though they appear different, is through compensation. So they can realize intellectually in their mind, hey, the reason why the glasses appear different is that they're shaped differently. They have the same amount of water, but they look different because one is shaped tall and thin, the other one's shaped long and wide. Also, during the concrete operation stage, children can do seriation. They can arrange objects in a specific order based on their relative quantity or size, or by their characteristics. So an example might be, they can arrange toys by lightest to heaviest based on feeling it. Or they often will arrange, let's say, numbers or quantities of, let's say, numbers from 0 to 1,000 using base 10 blocks from least to greatest. Another thing that's important to notice is that children can understand transitivity. So they can understand that through relationships and comparisons that they can make a conclusion. So an example of this would be, they know their mom is older than themselves, than the child, but they also know that the dad is older than the mom. So even though they don't know the dad's direct age, they can draw the conclusion older than the child. Because by default, if the mother is older than the child and the dad is older than the mother, then the dad must be the oldest. Here I'm providing a list of some developmentally appropriate learning activities for the concrete operational stage. One of them would be when you're practicing seriation. So this could be when you're having students use manipulatives to quantify a number or to organize from least to greatest, like base 10 blocks, like I mentioned earlier. Another activity that could be where students practice conservation is where they might use different size blocks to build two towers that are the same height. So this way they can learn that even though the actual individual blocks are different, the total height is the same. Another way that you could demonstrate transitivity, multiple classification, would be to have pictures of the animals and have the animals classify based on whether they were producers, consumers, or predators. So animals that eat consumers. And so this way students can not only organize animals by whether they're birds, reptiles, fish, but also they could show and demonstrate that animals can also have another characteristic and be grouped based on their eating or their diet. Furthermore, students can also learn through practicing transitivity. So maybe you could demonstrate this by having a student weigh a quarter on a scale, and then have a student weigh a feather on the scale, and then compare the two. Then and then the student determines, oh, the quarter is heavier than the feather. Later, just by holding up, by kind of comparing it through holding in their hands, they determine that a huge textbook is a lot lot heavier than a quarter. And so what they do is they can determine that, hey, without having to measure it, the textbook must be heavier than the feather. Another way you could demonstrate this is by practicing reversibility. So you could explain that division is the inverse or reverse operation of multiplication by having students make an array or a picture with rows and columns. So you might have students draw 5 rows and 3 stickers in each row, or maybe make that themselves on a piece of paper. Then you can demonstrate to students that multiplication would be 5 times 3 equals 15. And then you can show students how to work backwards by saying, what if we start with the total and then divide by the parts? So we divide by the 5 rows to get the number in each row, 3 stickers. Okay, we're going to discuss case study question in the same way we've done the other ones. So I'm not going to kind of reread the question because you've kind of already had experience with it. But please do this and then work and share with a partner. And then if you can, share with another group or another individual to evaluate whether you are correctly understanding the concepts. The final stage in Piaget's stage of cognitive development is number 4, or stage 4, the formal operational period. This is when students are ages 12 to adults. During this formal operational period, there's a greater variation in ability or characteristics of students. For example, it'll be a lot more noticeable developmental differences. You might have a 14-year-old student that's thinking at a college level, while you might have a 14-year-old student that still is barely able to think abstractly. And so there's a real difference and noticeable difference between how fast people develop. However, during this stage, people begin to think abstractly. They do not have to directly experience something to understand it. So an example of this would be, they know that ice is cold and that the temperature of ice is 0 degrees. They learned that, let's say, in third grade. However, they hear from a friend that the next day, tomorrow, it's going to be negative 20 degrees. And even though they haven't gone to the next day, even though they haven't seen the next day and they haven't they've ever experienced that ultimate low of negative 20 degrees, they do know that the water outside tomorrow is going to freeze and it's going to be colder than an ice cube inside, because they know that negative 20 degrees is colder than 0 degrees. Also, students are able to think hypothetically. So they'll be able to know that even if they have never experienced something, or even if something that could, let's say, never even occur in their lifetime, they can still understand it using principles they've learned before. So an example might be if a teacher gives students an assignment where they have to apply their scientific knowledge on the need for oxygen, the need for food and shelter, and then they take that knowledge and they apply it to a hypothetical example of living on the moon, which students might never see in their lifetimes, but still can connect to that hypothetical thought because they have such an ability to think abstractly. It is important to remember, though, that adolescents or teenagers in this period experience adolescent egocentrism. So adolescent egocentrism includes the following. So first of all, egocentrism means that you're focused primarily on yourself, or you think that you are unique. Obviously they're unique, but that your experiences cannot be shared. So the first type of adolescent egocentrism is the imaginary audience. So this is when teenagers think that everyone is watching them all the time, that all eyes are on them, and that everyone is paying particular importance to that specific person. So I remember, let's say like at a junior high or high school dance, I thought this way as well. I thought whatever I did, however I danced, whatever I wore, every single person in that room would be staring at me. and who I talked to and how I conducted myself, every single person would notice. However, in reality, everyone else was worried about themselves and worrying about maybe the person they liked, and they weren't really, only maybe a few people were really focusing closely on me. Um, so another example in the academic setting might be a teenager might hurry up and rush through a test because they see all their friends finishing the test, and they don't want their friends to notice that they're still working and think less of them. Another way that teenagers have this adolescent egocentrism where they think that they are unique and only they could experience something is the concept of personal fable. So in this situation, a teen thinks that their experience is unique and that they are basically invulnerable to negative consequences. So, or that just no one can relate to them. So one example might be how a teenager gets really frustrated and depressed because they think that no one has gone through um, a friendship ending or a fight with their significant other or problems with their parents. When reality is everyone has probably gone through that. Or that no one, maybe the teenager thinks, oh, no one has ever been in my position where they had to change schools in the middle of the year. But in reality, they have. Another thing that can be problematic with the personal fable is that sometimes students can have risk-taking behavior because of this. They might think that they are unique and invulnerable to negative consequences. So an example might be they think that, oh, I can engage in smoking. Even though they know that smoking causes significant health problems, they might think, oh, well, I'm different. I can quit whenever I want. I have good self-control. Another issue with the formal operational period is that teens can often make logical conclusions in their problem solving. Let's say you give them an academic problem and they have to solve it, or they might even be able to apply logic in social situations, but they start to struggle in that they think that the world is always predictable. They think that everything follows the same situation, that the generalizations are always true. So an example of this might be maybe a student in an ag science class. They've had lots of experience putting together an engine, and they put in several different types of engines, and maybe they have been able to assemble it correctly, and they know that if they have the correct instructions and they have the correct parts, then they can put an engine together. However, let's say that student gets faced with an unforeseen or unpredictable situation in which the predictable event is not predictable. Let's say the air temperature is so cold that any glue or oil or any cohesive materials that stick the engine together freeze and do not allow the parts to assemble. So another way to think of this would be like idealism. The concept that students think, oh, everything is going to be the ideal state. And so, however, their idealism or their expectation that all generalizations or all things are absolute and all things are predictable gradually reduces when they realize that they get more and more exposure to unpredictable situations. So someone or some type of person that they have assumed acts a certain way, once they get to know that another person of that group and they act a different way, then they realize, hey, I can't make generalizations about people. Or I can't also hold people to this ideal that all people are the same and all people act this way, when some people act uniquely in different ways. I would like to also include some developmentally appropriate learning activities for the concrete operational stage, so when students are ages 12 to adults. So one important activity might be a scientific experiment. In this way, you can help students inductively learn scientific laws. So let's say you have students experiment with different gases and different containers with gases and heating the gases. They could use that to determine their own laws of gas, and then through that you could connect it to the actual laws of gas and chemistry. Or another thing,
Another example of a learning activity could be providing students with authentic learning experiences and opportunities to have self-reflection. This way, they could learn, for example, in let's say a business class, what are their interests and research those interests, and then actually have um, authentic experiences of observing someone in that position, and then they can determine whether or not something is for them. They don't have just without any exposure, they don't have this ideal that being a doctor is really glamorous and it's easy and you just make a lot of money. But once they actually get exposure to it, they realize, being a doctor is very hard and difficult. Another type of activity could be a peer group assignments and group discussions. Since students need more and more interaction to break down those social barriers and to not be worried about their egocentrism that they're the only ones, to have small group discussions in which they later share out with their whole class helps accustom students to that people really aren't looking and analyzing every single thing they're doing, and that it's okay to make mistakes.
Here's our case study question number 4. It's the same type of questions, but with the formal operational period. Some important ways to apply Piaget's theories is to, first, activate students' background knowledge. Remember, we've talked a lot about the importance of schema and connecting the new information to the schema. And so, in order to make sure students make those connections to help retain that information, you have to make sure you remind students of what they already know and then connect what they've learned specifically to previous lessons. So, whatever you're going to teach them that lesson, you need to go back and explain to them what they have done before and how it relates to their prior knowledge. Second of all, it's important to also provide discovery learning activities. As we talked about, Piaget mentioned the importance of students learning for themselves and exploring and adding on to their existing knowledge through self-discovery. And so the way to do that is to have discovering learning opportunities where the teacher is not just telling students the facts or telling students what to do, but students are learning for themselves and they're exploring and coming up with their own conclusions. It also teaches them critical thinking skills. Third, it's also beneficial to provide students with problem-based learning activities. If you give them problem-based learning activities, students are seeing authentic examples and they're learning to understand the real world. This way they won't think that there's this idealized generalization that all students have to follow or all the world always follows. Remember, we talked about that just recently, how sometimes students they develop this idealism and they think everything goes this way. But yet the problem is when they get into the real world, they see that that life is not predictable. The world is not predictable. Therefore, it's important that they get exposed to problem-based learning activities so they can learn how to problem solve. They can evaluate their thinking, and then they can also adjust their perspective of the world. So they can realize that, yes, the world is unpredictable, but they can use their knowledge to solve their problems. Fourth, it's also very important that students are provided with collaborative learning activities. We discussed the importance of having students feel comfortable with each other and not feel like they are the only ones and that everyone is watching them. And so if you develop collaborative learning activities, students learn how to relate to each other. They also realize that people are not just there to criticize them, but actually to help them and to work together. Um, Furthermore, it can also allow opportunities for students to learn from each other. They can correct previous misconceptions or incorrect generalizations, and they'll develop social skills and will help them progress in their social maturity. For our case study, the final case study question, I want you to think how you would specifically apply Piaget's theories in your desired grade level. I want you to detail 3 specific instructional practices or learning activities that you would create for your students. And I also want you to pick new ones. I don't want you to do ones that you've already talked about in earlier answers. When you discuss in your case study the activities, I want you to first explain them, what you would have students do, and how and why those activities would effectively apply Piaget's theory. So what specific part of Piaget's theories supports that activity? And why would those activities be developed? Either those instructional practices overall, or those activities would be developmentally supportive of students' learning. Thank you very much for your attention.